Hello, and welcome to Mission 3, Lesson 6. All right, our student objective for this lesson, let's take a look. Our student objective is to multiply 2-digit multiples of 10 by 2-digit multiples of 10 with the area model. So what that means, in other words, is we're going to be multiplying 2 digits by 2 digits, okay, using what we're going to deem the area model, which you'll see here. Now, the key being is it says 2-digit multiples of 10, so we're only going to do those multiples of 10. So it's going to be like 20, 30, 10, 20, 30, 40, 50, 60, 70, 80, 90. And that would be a 2-digit multiple of 10. We're not going to get advanced yet and be like, we're going to multiply 92 by 52 or anything like that. Okay, so let's take a look here. All right. So, in a nutshell, this lesson you might be given a problem such as 60 times 30. 60 times 30. And you might be asked to use the area model to solve that. Okay? Remember, area is length times width. Okay? That's important for us to remember. Area equals length times width, because that's going to come up over and over again with multiplication using the area model. Length times width. All right. So let's say I was given 60 times 30. Well, since it's area model, we want to think of it in terms of a rectangle. Okay. So let's say I had that rectangle right here. And I know it's 60 by 30. So I'm going to label it. Oh, let me get my pen here. I'm going to label my sides. So my length is 60. My width is 30. Okay. Now remember, for area, we do length times width. So we do 60 times 30. Okay. But let's break it down to a little simpler term. Okay. What is 30? Let's think of it in terms of tens. How many tens is 30? Well, 30 is 3 tens. And then how many tens is 60? That's right. I just heard you in the back. 60 is 6 tens. Okay. So really what we're doing is 6 tens times 3 tens. Okay. 6 tens times 3 tens. And here's how you need to think of it. Is what we do first is we just do, well, what's 6 times 3? 6 times 3 is 18. And then I just do, well, what's 10 times 10? What's a 10 times a 10? It's 100. So 18 hundredths. Okay, so 18 hundredths. And what number actually is 18 hundredths? Well, the way I like to think of it is I know 100 has 2 zeros on it, so I just take 18. I put 2 zeros on it. So 1,800. 1,800. So that's really all we're doing in this. We're just taking, hey, 6 times 3 is 18. A 10 times 10 is 100. 18 hundredths, which is equal to 1,800. Okay. Let's take a look at one more here, just so we're safe. So I'm going to draw I'm going to be using this. And let's say I had, get my pen here, 40 times 50. 40 times 50. Okay. Notice again, these are just multiples of 10, 40 and 50. And so I'm going to label my sides here. That's 40. That's 50. And again, using the area model, so length times width. And I just want to rename the 40. 40 is 4 tens. And 50 is 5 tens. So really all I'm asking myself is, okay, I have 4 tens, excuse me. times 5 tens. Okay, and we're finding the product of that, the answer to our multiplication problem. So I just asked myself, well, what's 4 times 5? 20. And what's a 10 times a 10? Is 100. Okay, so 4 tens times 5 tens equals 20 hundreds. Now, I want to write it in standard form. So what's 20 hundreds in standard form? Well, I have 20. And then, again, I just asked myself, the way I like to ask myself, well, how many zeros does 100 have? 100 has, if I just look at like 100, 1, 2. 100 has 2 zeros. Now, here's the trick, though. It's 2 more zeros, 1, 2, to whatever you originally started with. Because even though 4 times 5 was 20, that 0 doesn't count. Okay? And then I just put on 2 more zeros at the end. And so, my comma where it needs to go. What's my product? 40 times 50 equals 2,000. Just like that. That's all we're doing. So that's the area model, and that's what we are using in this lesson. So again, just break it down into how many tens are on each side. And remember, 10 times 10 is 100. And otherwise, you're just multiplying a single digit by a single digit. As always, let me know if you have questions, or you can let your teacher know too, because that's what they're paid the big bucks for.